Hello guys, welcome to another session on Coding with Destiny. So we've been coding on C++ for some time, but I++, K++, J++ keep breaking your code. And why did NASA ban A++ from their Mars rover program? So today we're going to demystify C++ operators and save it from career ending. So get ready and let's go. Okay, so in C++ there are three types of operators, not just in C++ programming. The arithmetic operators, relational operators, and the logical operators. So we're going to start with the arithmetic operators. These are operators used for basic board math, like plus. Okay, let me just comment it out. We have the plus, minus, times, division, remainder. It's not modulus, it's remainder. Okay, so the plus and everything they work normally just the way we export. I just want to mention something about the division. The plus, minus, everything they work the same. Just for all types of data. So int x equal to 7, y is equal to 8. So you can just print out x plus y. And this will all give you correct answer, but like if you do x divided by y, the answer wouldn't be what we're expecting. So that's just what I want to show you here. The rest of them they work normally the way we expect them, but vision problem. So let's see what we're expecting in the terminal. Let's compile them, compile, then run. So you can see that the sum is 15. So we're expecting the difference 7 minus 8 is 1, 7 times 8 is 56. But the division is giving us 0. And this is because of the data type we're using, integer. Integer just ignores the decimal part of the number. So if you want to make sure you want to like be accurate to the precision, like this floating point precision, you have to use the data type that you're expecting. You have to like say change maybe x to float, to a floating point number. And if you compile this and run it, oh no, I've not compiled. You compile and you run, yeah, and now you can see 0.875. So you have to ensure that the data type you're using is the, like if you want the decimals to be included in the result, you use float in the integer you're dividing, in the number you're dividing. So that's just what I wanted to mention for arithmetic operators. For the remainder, let me also give an example of that. Let's say you have x as let's say 57, and then we wanted to show the remainder. Let me just add it in this our line here, and then we do x, the remainder when you divide it by y, lang is automatically formatting it for us. Oh no, there is an error. Yeah, you can't use float for remainder in, okay? You have to use x, you change x to an integer to avoid error occurrence. You can't use this operator with an integer, with a float. So you compile. Why am I not modifying this? Why am I not formatting this stuff? Oh, yeah. So let me clear my terminal to make it compile. Everything compiles well. We run, and we can see that the remainder is 1, because 8 times 7 is 56 and plus 1 is 57. So when you divide 7 by 8, it will remain 1. So that's the use of that operator there. So that's that for arithmetic operators. The next operator we're going to be talking about is the relational. So the relational operators are equal, like this double equal sign, that's like is equal to. No, assignment is different from assignment sign. So and not equal to. So these are like relational when it's used for comparing two data, like two variables, and then greater than, less than. So I think, okay, let me just give an example because maybe someone might not understand it yet. So let me say if x is equal to y, print x is equal to y, and then else print x and y are not equal. So let's see what is going to be printed out in the terminal. You compile and run. So you see x and y are not equal. Yeah, of course. 7 and this and 8 are not equal. So if you change this to 8, change x to 8, so now they are equal. Let's clear our terminal, compile, and you run. X is equal to y. So that's the use of this comparison relational operator. So if not equal to, if you change this to not equal to, the whole logic changes. So if x is not equal to y, we want to print x is not, and then here we want to print are equal if they are like not equal. If they are equal. So if they're not equal, we print they're not equal. Else they are equal. So we save, make sure you save, compile, and you run. X and y are equal. That's that. So for the greater than, less than, just works exactly the way you expect them to. So next up, we have our logical operators. These are used for like logic gates and things like that. Logical comparisons, like and. This is for and. If you want to combine two conditions, you use this and that. And or if you want to use, if you want something to if you want something to be true, if either of the conditions are true. If you want some code to happen to like be executed if either of the conditions in the condition bracket are true. So this and is when both of them have to be true for the code to be executed. And then the last one I'll talk about is not. So let me quickly show you how I'll use this. Let me just copy this block of code here, put it here. So if x is not equal to y, and let's say x is greater than y, you print x is not equal to y if, let's say, and x is greater. So if either of these things are wrong, you come here. So what are we expecting? X and y are equal. Yeah, that means they are either equal or x is less than y. So if x is equal to y, that means this part of the condition has failed, and automatically x is greater. y. So if both of them are equal, then this part of the condition you actually it doesn't really do much in this else loop, but here it actually does something. If they're not equal but x is less than y, that means our loop here still fails. So now in or x is greater, x is greater than, no, is less. Wow, and we run. So here we can see that x and y are equal or x is less than y. So which of them is the which of them is wrong here? X is less than y. So that is why it came down to this loop. But if we change this to, like, let's say 60, both conditions are true, and our loop will the if condition will be both true. X is not equal to y, x is greater. So I hope that clears that up. When we change this to or, the whole thing changes. So here will be or, and here will be and. So it only comes to this else when both of them are wrong. If either of them are true, this executes. It means that either x is not, we can even add here to make it as clear as A, B, C, D. Either x is not equal to y, or x is greater, or x is greater, yeah. So it's either any of them are true, one of them is true, or both. Doesn't really matter. When both of them are wrong, that means x and y are equal. This side that is broken, and x is less. This side is also broken. So if both of them are wrong, both are else loop. You combine your compile and run. Either x is not equal to y, which is true, or x is greater, which is also true. So both of them are correct. So if you make this 6, what do you think is going to happen? Try to guess. All right, let's see. I think you got it. You execute. X is not equal to y, or x is greater. So this part is wrong. X is less, but like x is not equal to y. So that side is true. So either one of them is true, and then we're in our up block. So I hope that clears that up. All right. So next up, we're going to talk about the increment operator. That is plus plus. Or okay, we'll have a lot of them. We'll have plus plus, plus equal to, minus equal to, times equal to. So let's say we have an integer I equal to 0, and then want to print out, let's just increment I. Let's say I plus plus, and then we want to print it out. So this increases the value of I by 1. Let's clear our terminal and compile and run. Yeah, I is 1. So this reduces the value of I by 1. This multiplies I by itself, and then like multiplies I by 1, and then post increment and pre increment. So to explain this, I would use an example. It's kind of pretty complex to explain, but like an example would do just that. Let's just see what this prints out. Let's do something like this. Let's print I plus plus versus plus plus I. So this is post increment and pre increment. Let's see what we're gonna get in the terminal and we run. Yeah, you see we got 0 and we got 2. I know some of you might be expecting 1 and maybe 2. Some of you might be expecting 1 and maybe 1. As I said, it increases it by 1. But it's about timing. So the post increment, it does something with I and then increases it. While the pre increment increases I and then does something with I. It's about the timing. So in loops, it's usually better to use plus plus I. Both of them, they will actually do the same thing, but it's about timing. The plus I plus plus, it creates a temporary object, while plus plus I doesn't. It just goes straight, increases the I, does what we want. So usually NASA banned A++ because it was creating temporary objects in their loops and making it kind of slow. So plus plus I, that is pre-increment, is slightly faster than I plus plus. So it's usually encouraged for you to use plus plus I in your for loops in whatever loop you want to do. So yeah, something like a J. So plus plus J here will be faster than J plus plus in this loop. So always use plus plus I in your loops. So the last thing I want to talk about is the ternary operator. That is, it looks like this. It's kind of called the operator. So if you want something to happen, like you want two different things to happen in two different situations, that depending on one particular variable, use ternary operator. So we have a number, it's called 50. Let's say maybe you wrote an exam and got 50, and then the string result is equal to this. The result is if you got higher than 60, you passed. But if it's less than 50, 60, you failed. So you know that everything depends on your score. So in this situation, this question mark sign is like, what is the value of what is score? Is score greater than 60, greater than or equal to 60? Then the first thing after the greater than the question mark sign is what you want. And then the next one is like the what you don't want. You're running. So yeah, you see that unfortunately you failed. So operators are your superpowers in C++. With great power comes great undefined behavior. So that's all for today. See you in the next one. Drop in the comment section the weirdest thing the operators have done to you in breaking your codes. Then like and subscribe if you gain something from this video. Refer your friends to my channel. Let's go together. Thanks for your support as always.